Welcome to lecture number 7 of chapter 1 C and C++ programming language. In our previous lecture, we learned about manipulators, operators, and some examples of operators. Our today lecture is about post increment, decrement, pre-increment and decrement, left value, L value, right value or R value, and examples of manipulators and operators. In first chapter, we use these 5 steps for solving any problem. The first step is write down the basic structure. Step 2, define variable. Step 3, get values of variables. Step 4, calculate the result. Step 5, show the result. Increment and decrement operator. Increment operator means increase one value to any variable. Decrement operator means decrease one value to any variable. Suppose we have a variable a is equal to 10 and we display it with cout. At output screen we see a is equal to 10. In next step, we increase value of a with a plus plus and display this value. At screen we see a is equal to 11. Mean one value is increased in variable a and we have a is equal to 11. In the same way, this code can be written as a is equal to a plus 1. The output will be the same, a is equal to 11. In next step, we use plus plus a, means increase one value to a variable. The output of this code is a is equal to 12, mean it increase one value to variable a and we have variable a is equal to 12. Both the code a plus plus or plus plus a increase one value to variable a. Other code for this plus plus a is equal to a plus 1. These codes are equivalent. You can write plus plus a or a is equal to a plus 1. Next we have decrement operator. A minus minus mean decrease a value in a variable and output is a is equal to 11. Mean we decrease one value from a and we have a is equal to 11. Same code, a is equal to a minus 1. In the next step, we have minus minus a and the output is same, a is equal to 10, mean decrease one value to variable a. Same code, a is equal to a minus 1. Post increment. A plus plus is called post increment. Plus plus a is called pre-increment. In the same way, a minus minus is called post decrement and minus minus a is called pre-decrement. Next we have pre-increment, pre-decrement, post-increment and post-decrement operator. Pre mean first increment or first decrement, then assign to value to another variable. And post mean first assign value to other variable, then increment or decrement the value in the variable. Suppose we have two variables, x is equal to 10 and integer y. When we declare these variables in memory, we have x and y, and value of x is equal to 10 in memory, and y is empty, only reserve a memory for y variable. In next step, we write y is equal to plus plus x, mean pre-increment in x. When this statement run, it first increase the value of x, mean increase 10 into 11, and we have x11. Then this value is assigned to variable y. So in y, we have y is equal to 11. Next, in post increment, suppose we have two variables, a is equal to 10 and integer b. In memory, we reserve a and b, and in a we have 10. Next, we increase value a plus plus, mean post increment in a variable. In post increment, first this value a is assigned to variable b, mean this 10 is assigned to variable b, and we have b is equal to 10. And in next step, a increase by 1, a plus plus, mean post increment, and we have a is equal to 11. The difference between these two increments, in pre-increment, first the value is increased, then this value is assigned to other variable, and in post increment, first this value is assigned to other variable, and then first variable is increased. Next we have L value and R value. L value means object that has identifiable location in memory, mean address in memory. L value is always a variable. L value cannot be a constant or number or expression or a function. R value means write value, object that has not any identifiable location in memory. R value may be a constant, a number, expression, or a value like x plus y. For example, we have an expression x is equal to 10. Here x is a L value and 10 is a right value. On the right side we have right value, and on the left side we have left value. And left value is always a variable. On the right hand we have expression, we have numbers, we have constants. Suppose we have variable integer x is equal to 10 and integer y. It's okay if you declare a variable in this way, it's okay. That create a location x in memory and save 10 on x, and also declare a variable y in memory. But if you write 10 is equal to x, that is not okay, because on the left side our L value must be a variable name. It cannot be a constant or a number, and we cannot write 10 is equal to x. That is wrong. Next we have x is equal to x plus y. It's okay. It means add x and y and save the result at x variable in a memory. In next step, if we write x plus y is equal to x, it is wrong. On the left side, we don't have any variable name. X plus y is not a memory location. That's why we cannot assign value of this x to x plus y. On the left hand side, we must have a variable name or memory location where we save our data. In next step, we have x plus plus. It's okay. It means x is equal to x plus 1. Mean simply increase one value to variable x and save this value to variable x. Next we have x plus y plus plus. That is not okay. It means x plus y is equal to x plus y plus 1. Right hand side is okay, but on the left hand side we don't have any memory location. X plus y is not a memory location. That's why we cannot save x plus y plus 1 result on x plus y. In first example, we get a number and display it. Just run it. Enter a number, for example 1, 2, 3, and we show this number with cout default decimal number. Now we convert this number into octal number. Run this program again. Enter a number in default decimal, number in octal. Again, we convert this number in hexadecimal. Run this code again. Enter a number, for example 28, and decimal 28, octal 34, in hexadecimal 1C. Next, we convert this number into uppercase hexadecimal, and no uppercase mean lowercase hexadecimal number. Run this program again. Get a number from user. Default number in octal, number in hexadecimal, in uppercase. B is converted into uppercase, and in next line in lowercase. In next example, set W and fill. Simply we set 10 width. Run this program, get a number. We set width up to 10 digits. One, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Total width 10. And next in fill, we fill spaces with steric. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total width is 10. Our next example is also set W and fill. In this example, we get 3 numbers from user and add these numbers. First number, second number, third number, and total of these numbers without set width and set fill. And next we use set fill and set W. Enter first number. For example, 1, 2, 3, 4, 5, 6, second number 12, third number 5. Without set W and set fill, it is difficult to understand and add these numbers. Whereas in set W and set fill, it is easy to fill and understand the numbers. Next example is about increment. We have x is equal to 10 and y variable. Run this code. We have integer x is equal to 10, y, and display x 10, and then increase one value, x is equal to 11, and assign this value to variable y 11 and increment one value and x is equal to 12.